So you mentioned there's a set of top questions you typically ask people when they're choosing windows. Can you review with us some of those top considerations?
Yeah, so usually when we're selecting windows, I usually look at windows and doors, and a lot of times we're picking the windows and doors from the same manufacturer. That way they kind of match. So it usually starts with energy efficiency. All of our clients usually hire us because they want some sort of green building standard, whether it's something very basic, where it's just like we're running a blower door, see how leaky the house is, and just getting like an energy rating for the house, or we're building a passive house. So with that, there's only certain windows that we can use. So that usually eliminates some of the less performing windows. And again, you can still use some of those less performing windows on the house if it doesn't last as long. The next thing I usually focus on is what are the colors, what's the aesthetic look of the house. So if they say that's like, well, we want a sleek, modern storefront looking window, well, I'm not going to get that from one of these wood windows. I have to go to something that's either fiberglass or metal or aluminum. There's certain brands and manufacturers that have that. If they say they want something that looks like that, but they want it to look like it's iron, well, again, I have to look at either an iron with a thermal break in it, or I have to look at one of these wood windows and get a certain finish to it to kind of mimic that look and give it that bronze, antique bronze, or black look what looks like it's wrought iron on the windows. If they want to stain it on the inside, again, you can't, this one comes pre-finished, or if it's a PVC window, you're not going to stain it. This one right here is fiberglass where it has the wood on the inside. You can stain it. The European window is all PVC. You're not going to have that option to stain it. Basically, the color that you have is the color that you get. So once I have a sense of the overall design aesthetic that they're looking for, and also the functionality, that kind of helps us narrow down the types of windows. And again, the windows are not going to be brand specific, it's going to be job specific. Once we ask them those questions, I don't usually ask them about like the solar heat gain coefficient or things like that. Those are things we just design into it. I try to get the best U value that I can for the buck for the clients. Look at the energy modeling for the house. Sometimes it makes more sense to offer a triple pane versus double pane versus adding more insulation to get the HVAC load down. Again, those are things we have to do with the energy modeling. I don't expect the client to know that, but if they're saying, I want this house to be zero energy ready, and I only want to spend this much on solar, well, I know I have to make up the difference in energy efficiency, and part of that is with the windows. So it's really qualifying the client, getting an overall energy efficiency perspective, design perspective, and also lastly, budget. I mean, each of these comes at a different price point. Um, the cheapest window, I tell my clients if they're over budget on windows doors, is the window that we don't install. Just making it a wall again, it's much cheaper per square foot for that surface area than it has to actually have an opening. It's cheaper that way, and also if you look at the performance of the house, we called these openings earlier. Every time you cut a window or door in, that's energy that's lost, because even like the best ones on the market, if you look at the U factor converted to R, this is going to be like maybe R4 or 5, which is a pretty decent window, regardless of the climate zone, where your wall assemblies are probably R15 to R20. So, maximum efficiency of a window is still only 25% of the wall assembly with insulation in it.
When you talk to your clients about cost, do you find that they're able now to look at a longer time horizon? Like, do they only look at the upfront cost of what this is going to cost them today, or if they're planning on staying in a home, say 5, 10, even 15 or 20 years, are you finding people more receptive to understanding about energy efficiency these days?
I think it's less about energy efficiency when they're looking at the long-term costs, and it's more about durability. They know that if they're getting like a shop-built painted window, it's not going to last as long, so that's why they're going with. I think the manufacturer's done a really good job selling the importance of a clad window. I think everybody knows what a clad window is, so I don't have to come in like where 20 years ago I'd have to educate people like, hey, this is a clad window. It's a wood window with armor on it. Now everybody knows what a clad window is. Now it's just determining, like, all right, what kind of cladding do you want? What color do you want? Do you want to change the color? So I think the market has, between consumers educating themselves and also manufacturers doing a good job educating the public, it allows me to focus in on some of those other questions where the list of questions used to be like 20 or 30. Now it's probably 10 to 12, and I could probably, if it's a more educated client, answer it in 2 to 3 questions.
So when we talk about windows and energy efficiency, we hear about U value, which I think is a pretty confusing concept for most people because we understand it in terms of R value, which often comes up with insulation. And I know that this all has to do with thermal resistance, but I think even in me asking the question, you can understand how this concept is confusing for a lot of people. So if you would, I'd love to just have an explanation for everyone out there, for our members. What really is U value? What is R value? How do they relate, and why is this important?
Yeah, so and to make it even more confusing, depends on where you are in the world. They even use other factors besides R and U value. So basically, most people understand that if you have more insulation in the wall, you have more thermal resistance. So if you have a piece of insulation, say like a piece of rock wool insulation, it's R4 per inch. If you have 3.5 inches, you're looking at R14 for that piece of insulation. So that means that's thermal resistance. So the actual definition has to do with how much heat it takes to heat up a calorie or burn a calorie or of material, and how long it takes to go through that material. So basically that's what it is. But as soon as we're talking about the same wall, but for some reason we go from the wall, the insulation, you might have like an average R value of R15 because you have wood in there. Wood is about R1 per inch. When you get to the window, the glass, it basically inverts. So if you have something that is R4, and to say this window is rated at R4, we're going to say it's a U value of U 0.25, which basically just 1 over 4. So if it's R5, it's 1 over 5. It's a U value of 0.20. So the U value is basically 1 over the R value. Now, when you're doing the energy modeling, you're typically converting everything to R or U. So if you're looking at the average effective range of the full wall, they typically convert everything to U factor at that point. But for some reason, we like to use different factors in different places. I know there's a reason for that, but I don't want to get into that. If you just want to be the cynic, you can say it's just to confuse consumers. But really, it's not really a fair thing. You have to understand, like the bigger the R value, the more thermal resistance you get. The lower the U factor, then the more thermal resistance you get through the glass. So, and it's usually that's for the glass. But you also have to look at the effective values for the whole assembly. So the glass can be rated at one point, but as soon as you start adding the wood, you start adding the frame to it, you start adding the divided light to it, then that also affects it as well. So typically the divided light is going to reduce it just a little bit. So that's going to affect the thermal resistance and whatnot. So I know it's confusing. There's reasons for that. We could probably write a paper on that. It's just like, why do Americans still use the imperial system instead of going metric? That's just the way it is, and hopefully we can change it.
I was going to ask you what STEMmy mean person decided we should change the letter and invert just for fun to make it more confusing for people. But I'm glad at least that there is a reason, and maybe not all of us have to know it. So on that, I guess I would just ask then, so just to clarify for people, higher the R value, the stronger, the better your insulation is working. The lower the U value, the better your window's working. Yeah. As you mentioned, you've got to look at it sort of average for the whole window. And you also mentioned average for the whole wall. So I need to look at what I'm trying to achieve for that wall, for that whole building. And you also talked about trade-offs. So I guess it would vary by climate zone, but are there normal averages someone will be looking for in their U value? Like is there a U value that makes a window kind of like a good or better window that are obvious, or is it really something you have to figure out for each situation?
Yeah, I mean, if you're designing a house, like a passive house, where you have to know the thermal break, the type of fasteners, and you're getting down to the nitty gritty, you're gonna have a different U factor or R value than we're talking about here. But what I tell people is, like, at least know what your code minimum is. So, and you can look this up on the internet, and we'll provide that in the link below, so you can see what the code minimum is. But also, just maybe a step above that, like, what is Energy Star rated? Energy Star rated is typically going to be, a certain percentage higher than the minimum code. And again, the minimum code now is probably, if you take like what the minimum code is in 2023 and look what Energy Star was in the year 2000, it's probably the same thing at that point. But because we're constantly making the energy code better, we're focusing on windows. They typically focus on windows, air infiltration, HVAC, heating, things that have to do with national security, which is energy. That's usually why they're constantly ramping those up and making it better. So if you live in an older house, even if you had it was a high performance house, say 50 years ago, a high performance house 50 years ago is a code built house today. Code built compared to high performance today, there's a huge difference. But if you look at like where we are today with the code built, a well built house, and if somebody follows the code to the letter, exactly to everything, and there's an inspector and they do it correctly, it's not a horrible house. The problem is most people strive to build down to the code, which means that the inspector's not catching everything. So if you're living in a code built house, it's probably less than a code built house because there's a lot of things that the inspector didn't catch, a lot of things that the builder messed up on. So you always try to do a little bit better. So I would start with the code, the energy code. Try to do a little bit better than that if you can afford it. But also, when you talked about U factor and R value, it really doesn't matter if air's going straight through it. So if you have air infiltration, if you have convective currents, energy is going through that. If you have convection, which is a form of heat transfer, U factor and R value just kind of go out the window. So you really want to have good ratings on the wall assembly, but you also want to make sure that air is not passing through it.
So let's take code as a minimum to try and do better and look up what high performance currently is. And it's great to hear you saying it really has been, and confirming it really has been a moving target and that things are getting better.
Yeah, in some markets, they're like, hey, why are some of these green building programs dropping off? It's like, well, quite frankly, the code's been getting better. So I know a lot of people, a lot of leaders say, hey, like the code is horrible, it's a D- or whatever grade they give to it. But you can take code design products, install them really well, and get a higher performing house out of it. Again, it has to do with the installation. So it's not just specifications, it's design, where you're putting it, and also how well it's installed. But again, a lot of this is going to come down to performance testing. So in our market, we have to have a blower door for every new house out there to get a certain infiltration rate. And I believe the national standard is 3 ACH 50, which means over an hour, you're only, I say, if a 25-mile-per-hour wind is blowing across the house, you're losing all the air 3 times. Well, you're losing the equivalent of all the air because obviously that's not a possibility. With passive house, it's 0.6. So that's why the tighter windows, the tighter building envelope matters a lot, because that's, I guess, 5 times better than the national energy code. So, and then some of our houses, we've got them down to like 0.1 to 0.3, and that's just at the sheeting level. So you can do a lot of work on the building envelope, and that's going to save you a ton of, that's the cheapest thing you can do. So if someone's asking me, is like, if I only have to do one thing on a house, and like I only have, say, $2,000 or $3,000 extra to spend, it may cost $20,000 or $30,000 for extra windows. But if they do this, and they don't focus on the sheathing on their house or making sure that the air is not going through the wall assembly, it doesn't matter that they spent all the extra money on this, because the high air infiltration rate, having that high ACH 50, 5 or higher, and like in one house we tested at 21, we could have put the best windows in the market in the house. It still would have been a leaky house. It would be like, yeah, whatever. It just goes around the window. So it's going to find the path of least resistance as the wind is blowing across it.
It's a great reminder, Matt, that even though we need to ask these questions and understand R value, U value, what's the best window, if you're not looking at the big picture and understanding that the sum is the whole of all the parts, and that that it really, our house is a system where all of the subsystems have to work together and they all impact each other. If we lose sight of that, then doing all this research into picking one factor for one product isn't going to magically give us a fantastically performing house that meets our goals.
I mean, you can't, this is a crazy analogy. You're not going to put a high performance gasoline into a riding lawnmower and then it's a NASCAR race car or Indy race car. It doesn't work that way. You have to look at the sum of all the components to make it a high performance house.
Thanks, Matt. There's a lot of great information here. I think that will really help people as they think about their windows, actually as they think about their whole home and their design and energy and health and comfort goals. I wish we'd had this conversation before I replaced my own windows, but I hope I know this information will help a lot of other people out there, and certainly including our members. So thank you very much.
Hey, not a problem. And the good news is we've talked to lots of different window manufacturers, so we have a full playlist, not only this video, if you want to make sure that you have all the questions answered regarding to like these windows, but also other windows in the past. We're going to have like 10 to 20 videos in that playlist, so make sure you hit that playlist over there, hit the like and subscribe button so you can get more great content just like this.